So now let's see how to write a chemical formula for transition metal. And non-metal. So what are the transition metals? They have more than one valency. So anytime you see Roman numeral in naming, you should know in binary compound, you should know it has involved transition metal. Now all these ones there, remember this periodic table is tiny, get your own, so you can just be tracing it out. So now all these ones there are transition metals. So they have more than one valency. They can form more than one compound. And all these group 4 here, carbon downward, they can act like transition metal too. That is why we can have carbon dioxide, carbon monoxide, carbon dioxide. They can form different compounds. So but the Roman numeral here always stand for the particular valency we want, because transition metal have more than one valency. How can we now know the particular valency in the naming? So the Roman numeral will state it. So in this case, so this is transition metal and non-metal. So let's write the chemical formula. So A, chromium 2 iodide. So now check chromium. You will see chromium is here, so it's in this circle. So now for this one, that means anyone that falls here is a transition metal. Thus we use Roman numeral for the valency. So now what is the valency for chromium? Here is the one you see here in the Roman numeral 2. Chromium symbol is Cr, so the valency is 2. That is chromium 2. So iodide, remember I said if you have IDE ending, then it's a non-metal, and it will be all those non-metal. And this is iodine, I. So if you check, iodine is in group 7. Yeah. So that is, it will have 1 as the valency. So it will not lose 7, to rather gain 1. So that is 1. So do your crisscross. So that will be Cr I2. So this is chromium 2 iodide. Now let's say I don't know, I just see Cr2 and Cr I2. So how can I name it? So now if I see Cr I2, I'll first look at it that what is chromium? Is it metal? Is it non-metal? Or is transition metal? So if I have confirmed that it's transition metal, I will know that my naming must involve Roman numeral. So chromium, what will I call it if I now see it, since it's transition metal? So that is why we need to underline chromium. So this will now look like, find the valency of the underlined element. So we've done this. Now the valency of the underlined will be X. Iodine is -1. So this is X minus 2 equals 0. So S equals to 2. That means the valency of chromium here is 2. So this is chromium 2 iodide. So you use Roman numeral if it's transition metal and non-metal. But let us assume this is metal and non-metal. Let us assume this is a metal and this is non-metal. All those subscript does not matter. I will just say chromium iodide. So but if it is not transition and non-metal, I need Roman numeral. So that means this is chromium 2 iodide. Now let's see the next one. B. Manganese 3 oxide. So check manganese. Manganese is Mn, so it's in your transition metal part. So that means this will become Mn is manganese. Why? Manganese 3. So that means the valency will be 3. Oxide, so that is oxygen. The valency is 2. So do your crisscross. So that will be Mn2 O3. So this is manganese Mn2O3. So this is manganese 3 oxide. But if this is metal, let's assume it's metal and this is non-metal, I'll just say manganese oxide, nothing will be attached to it. But so far it's transition metal, so this is manganese 3 oxide. But let us assume I don't even know the name and I say this. I'll first be sure that Mn is transition or is metal or is non-metal. If it is transition metal, I have to underline it and represent the valency as X. But if it is metal, I don't need to represent anything, I'll just call it straight. So now X oxygen is 2, so this will be 2s minus 6 equals 0, 2s equals 6, s equals 6 over 2, s equals 3. So the valency of manganese here is 3, so it's now manganese 3 oxide, I'll call it. So now let's move to the next one. So change this to nitride. So I'm not doing nitrates now, that is polyatomic ions. So now lead 4 nitride. Lead 4 nitride. Now lead is Pb. You will notice lead is in group 4. Now, and I've told you earlier that all these group 4 can act like transition metal because they divide the 8 groups into 2 equal parts. That is, if we are talking about group 1A, group 2A, group 3A, like that, up to group 8A. So they are the middle part. So they can act like transition metal. They can form different compounds. So now, lead 4. So because it's mentioned here, and remember I said if lead is not mentioned, take it as +2. But if it is mentioned, then use what you have there. So lead 4 nitride. So lead is Pb. Nitride is nitrogen. Remember it ends with IDE. That means it's a non-metal. So lead 4, the valency will be 4. Nitride, that will be nitrogen 3. So look at it. Group 4 we have 4 as valency, but group 5 we not have 5. From 5, 6, 7 we now carry 3, 2, 1. I've explained this, I'm just re-explaining. So now that means nitrogen belongs to group 5. It cannot lose 5, it will rather gain 3. So group 6 cannot lose 6, it will rather gain 2. Group 7 cannot lose 7, it will rather gain 1. So all those ones are their valency. That means nitrogen we have 3 as valency. So do your crisscross. So that will be Pb 3 and 4. So this is lead 4 nitride. So we use Roman numeral for transition metal. So now if I say this, now compare these two, Al2O3 and Mn2O3. Now compare these two. So if you look at these two, you see they have the same subscripts, but the way I will pronounce this one is a metal, while this is non-metal. Anytime I'm pronouncing metal and non-metal, I will just call it straight. So this is aluminum oxide. Nothing concern me with the subscript, it doesn't reflect in my naming. If it is metal and non-metal, we've done that in first video. So this is aluminum oxide. But if it is transition metal and non-metal, just like this, I have to know what exactly is the valency of this Mn, because transition metal have more than one valency, so I have to be sure what is the valency. So manganese is transition metal, so underline it and put S. Oxygen is 2 minus. So now 2 times x, that will be 2x minus 6 equals 0. 3 times minus 2. So 2s is equals to 6. S is equals to 6 over 2. S is equals to 3. So the valency of manganese here is 3. So that means this is manganese 3 oxide. So I use Roman numeral because it is transition metal and non-metal. So in the next video, so I'm doing non-metal and non-metal. So you see I categorize all this heading separately so that you can easily differentiate if it is metal and non-metal, transition metal and non-metal, or non-metal and non-metal. So the next one is non-metal and non-metal.